In this video, we're going to talk about relations and functions. Let us first proceed with relations. Let me give you examples. First example we have here, love couples in the game Mobile Legends. Second example, we have here countries and the flags that represents them. Next example, we have here basketball players and their numbers that corresponds them. Next, we have here private employees and their SSS numbers. We also have here positive numbers and their negatives. We also have here numbers and their squares. Okay, so from those examples, let us define what is a relation. So if you're going to observe in our examples, we have here set A and set B. And what is a set? So a set is a group with elements that have characteristics or properties in common. Okay, so in this example, we have here set A and set B. And a set means that the group should have common characteristics. These are group of male characters and these are group of female characters. Here in set A, these are group of flags, and in set B, these are group of Southeast Asian countries. In this example, in set A, these are all basketball players and a team, and in set B, these are all numbers. Here in set A, these are all private employees, and in set B, these are all SSS numbers. In this example, set A are all positive numbers and set B are all negative numbers. In this example, set A are all numbers and set B are all perfect square numbers. Okay, so those are their common characteristics. Now let us define a relation. A relation is a rule that relates values from a set to a second set of values. In this example, what makes this relation is they are love couples. Here, what makes this relation is these flags represent these countries. And here, the negative numbers of these are these numbers. In this example, the rule is if you're going to square this number, the result is 1. So the rule here is these numbers are the square of these numbers. Okay, so our relation has two sets. We have set A and set B, but there are proper terms to call these sets. For set A, we call it as the domain, and for set B, we call it as the range. And usually the symbol for domain is X and for range is Y. What is a domain? Okay, domain are the inputs in the relation and range are the outputs in a relation. So for example, if you're going to input 1 in a relation, expect that the output will be negative 1. Why? Because the rule here is these numbers are the negatives of these numbers. So if we have here 7, the negative of this is negative 7. So we call set A the input and we call set B the output. So since the domain are the input and range are the output, we also term them as independent and dependent, because the values here in set B depends to the values of set A. For example here, so the rule here is if you are going to square a number in set A, the result should be in set B. So for example, 1 squared is equals to 1. If you are going to add 6 in set A, therefore you should add 36 in set B, because the square of 6 is 36. So in set B, you cannot add 49 because there is no 7 in set A. So we are going to remove 49. That makes the elements of the range will be dependent on the elements of the domain. Okay, so let us proceed with the three types of relations. First, we have one-to-one relation. Second, we have many-to-one relation. And last, we have one-to-many relation. So, from our previous examples, those are examples of one-to-one relation. Now, let us see the difference of these three types of relations. For one-to-one, each element of the range is mapped to one element of the domain. For many-to-one, you can find two or more elements of the domain that is mapped to one element of the range. So for example, here we have 1 and -1 is mapped to 1. And 2 and -2 is mapped to 4. For one-to-many, you can find one element of the domain that is mapped to two or more elements of the range. For example, 1 is mapped to -1 and +1. 4 is mapped to +2 and -2. And 9 is mapped to -3 and +3. There are many ways to represent relations. First is through mapping, wherein we're going to connect the elements of the domain to the elements of the range using arrows. Next, we have here set of ordered pairs, wherein we're going to list the elements of the domain in range in pairs. Here we're going to use the set notation, which is called the curly bracket. We can also represent these relations through equations, and we can also represent these relations through a graph. From these three types of relation, only one-to-one and many-to-one are considered as function, and one-to-many is considered only as mere relation. Okay, so let us define what is a function. A function is a type of relation such that every input corresponds to exactly one output. In symbols, we say that for every x, there is exactly one y. Now let us learn how to identify if a given relation is a function or not. Okay, so if the given is mapping, we are going to look if each element of the domain is mapped to one element of the range. For our first example, observe that each element of our domain is mapped to only one element of our range. In our second example, we can also observe that each element of the domain is mapped to only one element of the range. In our third example, observe that you can find element of the domain that is mapped to two elements of the range. For example, 1 is mapped to two elements of the range, which are -1 and 1. So from these three examples, example 1 and 2 are considered a function, and example number 3 is a mere relation. If the given is a set of ordered pairs, we need to see if there are x values that are repeated. For our first example, you cannot determine a value of x that is repeated, same with our second example. But from our third example, observe that 1 is repeated as value of x, meaning this is a mere relation, and example 1 and 2 are functions. If the given are equations, and if you cannot determine a number, that if you're going to substitute in x, there will be two results, then it is a function. In our first example, if you're going to substitute any number, the result will be always one number. For example, number 2, if you're going to substitute any number, the result will be always one number. In our example number 3, if you're going to substitute one number, the result will be two numbers. Okay, so let's try to substitute 4 in this equation. Y squared equals 4, and then let us solve for y. Y is equals to positive and negative 2. As you observe, when you input 4, the result is two numbers. Those are positive and negative 2, meaning this is a mere relation, and example 1 and 2 are functions. If the given is a graph, we are going to have here vertical line test, wherein if you're going to draw a vertical line anywhere in the graph, and if it crosses the graph at exactly one point, then it is a function. But if it crosses the graph more than once, then it is a mere relation. So for our first example, let's try to draw a vertical line. Observe that it just crosses the graph at only one point. In our second example, observe that it just crosses the graph once. In our third example, if we're going to draw here a vertical line, observe that it crosses the graph twice, meaning this is a mere relation. And our first two examples are considered as functions. Okay, so if you know that a given equation is a function, you can use the function notation as a substitute for the variable y. So what is the function notation? The commonly used function notation is we have f of x. So this is read as f of x, not f times x. So we use this function notation as a substitute for the variable y. We can use also other letters like h of x, or we can use also capital letters like j of x. Okay, so for this example, we can rewrite this as f of x equals negative x, and for this example, we can rewrite this as f of x equals x squared. We can also have here h of x equals x cubed plus x squared plus x plus 12. This is an example of a function because you cannot find a number that if you're going to substitute to x, the result will be two numbers. Another example of a function is k of x equals 14x squared. And last example, we have here y equals 2/3 x. Okay, so let us end this video with an activity. Post this video and then try to answer. The task you're going to do is you're going to identify which of these items are function and which of these are mere relation. Okay, so post this video. Okay, so let us check your answers. Number 1 is a function because you cannot see an element of the domain that is mapped to two numbers in the range. Number 2 is a function also because you cannot see any element of the domain that is mapped to two numbers in the range. Number 3 is a mere relation because you can find a number that is mapped to two numbers in the range, that is 6, which is mapped to 9 and 20. Number 4 is a mere relation because there is a repeated value of x that is 2. Number 5 is a function because you cannot find a value in x that is repeated. For number 6, this is a function because you cannot find a number that if you're going to substitute to x, the result will be 2 or more numbers. Number 7 is a function. Okay, so this is the rule of the square root. Okay, so let us try to substitute a number in this equation. So let's try 2. So y is equals to square root of 2 times 2, and that will be square root of 4. So we're going to consider only the positive square root. So the square root of 4 is 2. Okay, so that shows that this is a function. Number 8. Okay, so number 8 is a mere relation because you can determine a number that if you're going to substitute to x, the result will be two numbers. Let's try to substitute 2. So y squared equals 2 plus 2. Then let us solve for y. So that will be y squared equals 4. To solve for y, we're going to get the square root of both sides. So y, so this will be cancelled. So y will be equals to positive and negative 2. As we said earlier, if the square root is in the original equation, we are going to consider only the positive square root. But in example number 8, the square root here is not in the original equation, so meaning we're going to consider the positive and negative square roots. But the exemption here is if you're going to solve distance, always the answer will be positive because there are no negative distance. Okay, number 9. Number 9 is a function, because if you're going to draw a vertical line, the vertical line will only cross the graph once. And number 10, this is mere relation, because if you're going to draw a vertical line, it crosses the graph twice. Okay, so I hope you understand what is the difference between a function and a mere relation. Okay, so that activity concludes this video.